Hi guys. So we're back with a new topic today: logarithmic differentiation, which I didn't spell right here. Hold on. Differentiation. Right. There you go. Anyway, this really should just be a continuation of the previous section. I think the last video was short, and this should have just been part of it, but it's not, so it's its own thing. So logarithmic differentiation. What is it? Why do we care? Right. So in the previous section, you did integrals. No, you did derivatives like this. So in the previous section, you did derivatives like this. So something like this. If I give you f of x equals, let's say, ln 3x over sine x plus x cubed, then that's a derivative that you would know how to do, right? And the key to doing that derivative was using the log rules, right? Because if you use your log rules before you take the derivative, you can make it a lot easier, right? So how would that look? So you would use your log rules first to expand everything here. So we're not doing a derivative, we're just using the log rules. Okay, hold on, I'm gonna change this. There we go. It doesn't have to be like this, but I just want it to be. So, all right, use the log rules to expand this. So you had a rule for when you had a log of a fraction that you could split that up into two logs. Log of the top part of the fraction, minus log of the bottom part, which I changed to that. Then you had another rule that said when you had a log of two terms multiplied that you could split those up into two logs of a sum. Like so. And then you had another rule that said if you have an exponent like that on a term inside of a log, that you can take that exponent and move it down in front. While I'm at it, I'm going to distribute that minus sign right there. So ln 3x minus ln sine x minus 3 ln x. Right? And that's before you take any derivatives. But the point of doing this is now each of these terms is a much easier derivative for us to take using the basic rules for the derivative of a log, right? So here's what we need. You need to know that the derivative of ln x is 1 over x. And technically I could split up this right here into two logs, but I'm not going to bother because when you do the derivative of ln 3x, it's 1 over 3x times the derivative of what's inside for the chain rule, which is just 3, and then your 3's just cancel. So that's easy enough that I don't need to split it up. So once you have it all expanded, then what you want to do is differentiate, and it should be easy. We just finished saying that the derivative of ln 3x is just 1 over x. The derivative of ln sine x is going to be 1 over sine x times the derivative of what's inside. The derivative of sine x is cosine x. And then the last one, minus 3 ln x. Well, the derivative of ln x is 1 over x. So this is 3 over x. Like that. And then to finish this up, I guess there's a couple things we could do. Probably what I would do is I would just take this 1 over x minus 3 over x. That's negative 2 over x. And then here, the cosine and the sine, I'll just combine those because a cosine over a sine is a cotangent. So there you go. And that's your derivative. Now, in theory, this is what you learned in the previous section, right? This is not a new thing. I'm just reminding you that these derivatives are relatively easy. Now, the reason you can use log rules is because, of course, they're in the logarithm, right? So in order to be able to do these steps here, right, you need logs to do this. Well, what if you have a derivative that you're trying to calculate that doesn't have a logs, but if it did, would be nice? Well, that's what logarithmic differentiation will help you with. So if you start out with something like this, have to differentiate something like this. Let's just say g of x equals like x cubed e to the 5x over sine x. Like, you wouldn't want to do that derivative, right? Because you'd have to do a quotient rule, and in the middle of your quotient rule, because the numerator is a product, you would have to do a product rule. So it's product rule and quotient rule. And you would prefer generally not to do that, right? So you would have to use the quotient rule, because it's a quotient, and the product rule, because the numerator is a product, in order to evaluate this derivative. Or, you can use logarithmic differentiation. Differentiation. Writing's hard, guys. Okay. Or use logarithmic differentiation. So the idea of logarithmic differentiation is that you're starting with something without a logarithm, and you're going to add the logarithm and then differentiate. So I'm going to write the idea here, and then I'm going to move on to the next page and actually write real steps. So idea 1. You start out with no logs, right? Like the one that I just wrote there for G. So then what you're going to do is take a log. Now that you've had a logarithm, you can use log rules. Use log rules. I said I was going to write the steps on the next page, but I'm writing them all here. So start out with no logs, take a log, use log rules, take derivative, and then you undo the log. Okay? That's the basic idea of this whole process here. Now, it really doesn't make sense unless you are going to work through an example, and so that's what we're going to do. We're going to work through an example. So we might as well just do that one that I call G. That one's fine. So g of x, which I already forgot, it is x cubed e to the 5x on top, sine x on bottom. All right. And so here are the real steps. So your first step is going to be generally what you're going to do is if your function is called like something like g of x, a lot of times I'll rename it and I'll just call it like y or something. It's kind of optional, but you do want to have two sides of the equation here. So like, actually, I'm even going to change this. I changed my mind. So like, let's say that you're told to evaluate this derivative. Okay, you wouldn't be able to do it right away because you do need it written as two sides of an equation. So if necessary, add like y equals basically. And all you're doing there is you're giving it a name. Now, I don't like using f of x and g of x for those, so I pretty much always do this. And I recommend that you do too. So like y equals x cubed e to the fifth over sine x. Okay? So we didn't really change anything. We just added the y equals. Now, then what you're going to do is, this is where you take your log now. Now you take the natural log, ln of both sides. So you need a both sides in order to take the natural log of both sides. So just ln y equals ln x cubed e to the 5 sine x. All right. So you take the derivative of both sides. No, you don't take the derivative of both sides. You take the natural log of both sides, and then the next thing you want to do is apply all of your log rules. Just like we have on previous derivatives. So that's pretty easy. Again, a lot of times when you're doing this, you've got fractions. So we've got a fraction, so we should change it into natural log of the numerator minus the natural log of the denominator. All right, that's one rule. But we got more to do. Then we've got natural log x cubed e to the fifth. We can split that up into a sum, ln x cubed plus ln e to the fifth minus ln sine x. There's nothing to do with the ln sine x, so we just rewrite it. That looks, I was going to say as good as we can do, but it's not. If you want, you can bring the exponents down. You can bring this one down, and if you want, you can even bring this one down, but that's not going to matter because that's going to be a constant there. Did I really write e to the fifth? Hold on. Oh, I'm so dumb. This had an x on it, right? It makes a lot more sense to have that. If it's just e to the fifth, that's just a number. I'm changing it. I'm changing this to 5x. Okay? Changing them all to 5x. 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 Okay. So then we are going to bring down all of our powers using the rule for that. So you bring the 3 down in front. You have 3 ln x. You bring the 5x down in front. You have 5x ln e, I guess. You don't really need to do that. And then minus ln sine x. All right, so now we're done applying log rules. So once you're done applying your log rules, then you should just be able to take the derivative with respect to whatever variable you want. Take derivative. In this case, it's d dx. Why? Because that's what it said up here. All right, so you have d dx ln y equals d dx all this stuff. Okay, I'm going to try to copy this. I have no idea how to do that. Wish me luck. Okay. How do I move it? Oh. That was amazing. All right. Now that you've got that, then we take our actual derivative. So when you take the derivative over here, you've got to remember implicit differentiation. And I know that that is scary because implicit differentiation is hard, but it's not hard in this case, right? So the basic idea of implicit differentiation is this. The derivative of a function of x is just the derivative of a function of x. The derivative with respect to x of a function of y, or any other variable, right? So the point is that this variable and this variable are different variables. You take the derivative like normal, and then you have to multiply by y prime. And that's just the chain rule, but when we do it like this, we call it implicit differentiation. So what that means over here for us is you take the derivative with respect to x of ln y, and you're going to get 1 over y, right? That's just the derivative of natural log. But because this was a derivative with respect to x of a function of y, you've got to tack on a y prime. And that's it. So that little bit of implicit differentiation, you're going to be doing on every one of these problems. But it'll be the same thing every time, so don't worry about it. So 1 over y prime. On the other side of the equation, now we just take the derivative. So our first thing is 3 ln x. So the derivative there is going to be 3 over x, right? 3 times 1 over x. Our next term is 5x ln e. Ln e is just a number, right? So what's the derivative of 5x? It's just 5. So this is just 5 ln e, which is 1, by the way, but I'll change that in the next line. Or, yeah, ln e is 1. All right. Last one, ln sine x. So the derivative of ln sine x is 1 over sine x times the derivative of what's inside, which is cosine x. And there you go. That's your derivatives. Now, before we move on, I want to clean this up just a little bit. 3 over x. Ln e is 1, so this is actually just 5 here. Remember, right, like the rule for logs was like this. Ln e to the, all right, a is a, and a to the no, hold on, I would write that wrong. Nope, erase. Nope, erase. E to the ln, ln e to the a is a, and e to the ln a is a. With the point being that the exponential and the natural log cancel out when you compose them because they're inverses of each other. So when you do ln e to the 1, it's just 1. So that's 5 times 1, which is 5. And then here, just like last time, cosine over sine was a cotangent. Okay? Now, at this point, what you've got here is you're almost done, right? What you're supposed to be doing is finding the derivative of y, right? Because back at the beginning, your original function was called y. So you need to solve for y prime, which we're going to do. And after we do that, I'm going to make a correction to somewhere earlier in the notes. So if you're trying to solve for y prime, you just need to make this y move it up to the other side. So if we do that, you're going to get y prime equals y 3 over x plus 5 minus cotangent x, right? And then we're almost done. So you've got one more step after taking the derivative here. Oops, hold on a second. Back this up. Today is not going very well. Clean this up. Take that, move it down. Six. We took the derivative, After you take the derivative, you want to just move the y over to the other side. Always going to work like what we just did. And then your last step is really just replace the y with whatever y is. What y is. And that's actually really easy too. Just scroll up a little bit and we'll see what y is. So we scroll up, scroll up, scroll up, scroll up, scroll up. Well, right here, right? There's your y. It's x cubed e to the 5x over sine x. It's what you started with. So replace the y with what y is, and you get y prime is y, which was, already forgot, x cubed e to the 5x over sine x. X cubed e to the 5x over sine x. Like that. And then the rest of the stuff you just write. Okay. And that's your derivative. So, what's that mean? I think it means we're done. That's your answer. Okay, and that is logarithmic differentiation. So let me back up to where I was writing instructions. And in my head, I'm just kind of getting mixed up here. So I said, start out with no logs, sure. Take a log, sure. Use log rules, sure. Take a derivative, sure. Undo the log. Well, we didn't undo the log, right? That was not what we did. What we actually did was we just solved for the derivative. Solve for the derivative with algebra. And then that's it. Okay, so we solved for the derivative with algebra, which is just those last two steps. All right, and that process there, that's logarithmic differentiation from beginning to end. And what we just did there, that example, I'll say it's not like the hardest, most difficult example you're going to see, but it was one of the harder ones. So here's one that's just straight off of your homework example. If f of x equals 5x to the 9x, find f prime of 2. Okay, and it wants an exact answer. Give exact answer. All right. Now, this is kind of an interesting example too, by the way. So if you think about it, so this is just kind of a note here. You know how to do certain derivatives. You know, right? You know how to do the derivative of like x to the n, right? Of course, that's nx to the n minus 1. And you know how to do the derivative now of, let's say, a to the x, because that's a to the x ln a. You learned that 2 lectures ago, right? But you don't actually know, because you never learned, d dx x to the x, right? So you previously knew how to do this when x was the base and when x was the exponent, but now x is the base and x is the exponent. And so that's a little bit weird. And it's just a function, but it's a function that you never learned how to take the derivative of. And so this one here, if you look at it, 5x to the 9x is basically that, right? The 5 and the 9 are extra, but actually they don't matter very much. So let us take this derivative and see how it goes. So what do we got? No. So we've got f of x equals 5x over 9x. Now, like I said, I like to rewrite this as like y equals 5x to the 9x. Like that. It's just easier to have a y than an f of x for me. All right, so how are we going to do this? We're going to take log rules. Or sorry, take log first. Take log. ln y equals ln 5x to the 9x. All right. Then what do we do? Derivative? Nope. Log rules? What kind of log rules? So ln y equals, and we just need the log rule here that will let us take the 9x out in front. So that's the only one we really need. Take that 9x in front. 9x ln 5x. Okay? Good enough. Technically, you could use another log rule on the ln 5x. I am not going to bother. Okay. After we do our log rules, now we actually do the derivative. Okay, so I'm going to write this d dx ln y equals d dx 9x ln 5x. Okay, so we want to do this derivative. Now keep in mind though that this derivative here, we've got a 9x and then we've also got an ln 5x. So we're going to need the product rule there in order to do this. Product rule when we do this derivative. Let's do the left-hand side first though. So d dx ln y, how do we do it? Well, 1 over y prime. Right? And that's implicit differentiation, but remember on the last problem I said it's the same implicit differentiation in every one of these problems. So just remember 1 over y prime and you're good. Okay, so now let's take the derivative of 9x ln 5x. So we need the product rule, so that'll be like 9x prime ln 5x plus 9x ln 5x prime, and then we take those derivatives. So we've got the derivative of 9x is 9. And the derivative of ln 5x is 1 over x. Right? If you do the chain rule, it's 1 over 5x times 5, and then the 5's cancel. Now, right away, I just noticed that this x is going to cancel with this x. So we're just going to have 9 there. So what do we want to do? We want to solve for y prime. So we got y prime equals y, and over here, I'm not doing very much yet. I am just going to write it as plus 9 and stop there. And let's see here, what else? Last step, well, actually not. Second to last step, we need to replace y with what y is. What it is. So y prime equals, actually, hold on, back this up. Y prime equals, what is y? Y is 5x to the 9x. 5x, 9x, 9 ln 5x plus 9. And that's the derivative. So we're done with the derivative, but if you look back up at the original problem, it says specifically that we're supposed to be looking for f prime of 2. So we still need to plug in a 2. So f prime of 2. Now remember, f prime is just y prime because I renamed the function y. So f prime of 2 is, let's just put it in, you got 5 times 2, which is 10, 9 times 2, which is 18, 9 ln 5 times 2 plus 9. Squeeze this in on this page. So you have 10 to the 18, and then 9 ln 10 plus 9. And that should be your answer. Okay, and there you go. That is logarithmic differentiation. I'm going to click through a couple questions and see if I see anything really interesting in the homework, and then we'll end this video. I think no, I think this is it. Yep, okay. So you really only have ones that are like that first example or ones that are like that second example. And that is logarithmic differentiation. So this homework is due Tuesday, so you got a while to work on it. That's it for now. See you in the next video. How do I stop?